you've been told a dynamic system is characterized by a differential equation d squared x over dt squared plus 2x over dt minus 3x is equals to 12 cos 3t. If t is equals to 0, x is equals to dx over dt is equals to 0, then use Laplace transforms to find the expression for x of t, isn't it? Now, the first thing we need to know is how to get the Laplace transform of each and every section, isn't it? So we start with the second order differential. There we have what is the Laplace transform of d squared x over dt squared, isn't it? So we say you start, if it is squared, it means you're starting from s squared, isn't it? Yes. Then Laplace transform of x, isn't it? Then Laplace transform of x, then it is minus, you reduce the power by 1, then x of 0, isn't it? Yes. Then if you reduce, when it is x raised to power 0, it means x is now silent, isn't it? Yes. Then you now differentiate this for the first time, it becomes x prime of 0, so there. Yes. Look, if it is d squared, meaning we are going to start from s squared. Then Laplace transform of there. Remember, we are dealing with the independent variable x. What is the variable in the numerator, isn't it? Yes. X throughout, isn't it? Are we together? Yes. Then we go to this part, dx over dt. So what is the Laplace transform of dx over dt? So here the power is 1, isn't it? So it means it is s raised to power 1, isn't it? Then Laplace transform of x. Then we reduce the power of x by 1, it is s raised to power 0, meaning it is now silent, isn't it? Then we have x of, because s is now silent, we now have x of 0. So it means we are ending there because s has ended, s raised to power 0, so there, which is silent. Are we together? We are done with this. We move to this next one, is x, isn't it? So the Laplace transform of x is just the Laplace transform of x because it's the independent variable throughout, isn't it? Yes. Are we together? Then the next is Laplace transform of 12 cos. So you can say the Laplace transform of cos 3t. It is the constant we are not dealing with. We are dealing with the functions, isn't it? So what is the Laplace transform of cos 3t? You know the Laplace transform of a cosine function is given by what? S over s squared plus a squared, isn't it? And our a is 3. So a squared is going to be what? 9, isn't it? Yeah. So that is s over a squared plus a squared when you are looking for the Laplace of cos at. And our a is 3, isn't it? Are we together there? Yes. That one you will be given in the table. You will be given in the table Laplace transform of cos at to be s over s squared plus a squared. So our a in this case is 3, where there is a you put 3. So 3 squared you get 9, isn't it? Good. Now, having found the Laplace transform of everything, you substitute them in the equation, isn't it? So before you substitute there, you know we are looking for the x of 0 and x prime of 0, isn't it? So what do you do that? X is the independent variable. You are differentiating with is the dependent variable you are differentiating with respect to t, the independent variable, isn't it? So if you are differentiating x with respect to t, meaning x is the function of t. Are you seeing? Meaning a function you can use anything to denote. So if it is x, we're just using x to denote a function. Are we together? Yeah. But in many cases, you can say if x is in terms of t, you say x is a function of t like that, isn't it? But this symbol, this letter for denoting the function is where we are saying you can use any function. So in this case, we are using for the same letters to avoid a lot of unknowns. Are you getting that? So x is a function of t. So once you identify x is a function of t, meaning if you differentiate x, you get x prime. It's the same as the function of x prime of t. So there. Are we together? Yes. Remember, if you are differentiating here, this x prime, if you are differentiating x with respect to t, it means this is dx over dt. Isn't it? Are we together? Yes. Then you go and check. What are you told to be x? You are told x is equals to 0, meaning this x is equal to 0, and you are told the x over dt is also 0. Then you are told to take t to be what? To be 0, meaning where you see t you put 0. Are you seeing that? So we've seen in our Laplace transform the x of 0, we can now see x of 0 is 0. Are you seeing that? Yes. And from the Laplace transform we can see x prime of 0 is also what? 0. And this we can construct from the initial conditions and there, isn't it? Are we together? So, having found everything, you now substitute them into the equation. So start, the first part we have d squared x, everything in this bracket. D squared x over dt squared. If you substitute this, what have you found it to be? S squared, then x of 0 you found to be? Meaning that one will go to 0, isn't it? The x prime of 0 you also found to be 0, meaning the whole of that term will also go to 0. Are you seeing that? X of 0 you found to be 0, meaning that will go to 0. Are we together? So the Laplace transform of this, what will you do? This is what you will do to be procedural, meaning you introduce Laplace all through, isn't it? Meaning Laplace transform of d squared x over dt squared plus 2 Laplace transform of dx over dt. We say the constant can be factorized outside. We are introducing L all through, isn't it? Are we together? Then if you introduce L here, you have negative 3 Laplace transform of x is equals to 12 Laplace transform of cos 3t. Are you seeing that? Yes. Meaning you've introduced Laplace on both sides of the equation and you factorize out the constants, isn't it? Then you substitute. So what is the Laplace transform of d squared x over dt squared? You found it is s squared Laplace of x, then it is plus 2 into, what have you found to be the Laplace transform of dx over dt? It is s, yes, Laplace of x, then we have minus 3, then Laplace of x is just Laplace of x, isn't it? Then 12, what have you found to be Laplace transform of cos 3t? S over s squared plus 9, isn't it? So that is s over s squared plus 9. So what we want to make the subject, because we are looking for the expression of x of t, so we are making the Laplace of x the subject, isn't it? So before you do that, you open the bracket. So we have s squared Laplace transform of x plus 2 times s, 2s Laplace transform of x minus 3 Laplace transform of x, 12 times s, 12s over s squared plus 9. So if you factorize out a common factor, Laplace transform of x, what do you remain with this side? Here you remain with s squared, here you remain with plus 2s, here you remain with minus 3 to be equals to 12s over s squared minus plus 9, isn't it? Then you divide both sides by this coefficient for you to remain with the Laplace of x, isn't it? So you get the Laplace transform of x is what? Is 12s over, you divide both sides with this, isn't it? So that one is a factor, so it is 12s over s squared plus 9 times s squared plus 2s minus 3, isn't it? Yes. If you divide both sides by this. So if you divide both sides by s squared plus 2s minus 3, you divide both sides by s squared plus 2s minus 3. That goes with that. You remain with your L of s, isn't it? Now, for us to get x, we take Laplace, the other side it becomes Laplace inverse. And we cannot do that before we separate this by resolving into partial fractions, isn't it? So we see, when you are resolving into partial fraction, what do? We noted that the quadratic factor, which cannot be factorized into linear factors, remains as a quadratic factor, isn't it? And the one which can be factorized into linear factors, you factorize, isn't it? So if you try to factorize x squared plus 9, you'll see that you will get a complex factor, because s squared plus 9, if you have there to be equals to 0, you get s squared is negative 9, isn't it? If you find square root on both sides, you get s to be plus or minus 3j, because negative square root of negative 1 is j, isn't it? So from there you get your s plus 3j and your s minus 3j to be the factor. So those are complex factors. So any of them which is giving you a complex factor, you leave it as a quadratic factor. Okay? Are we together? Yes. You leave it as a quadratic factor. Then you go to the other one, s squared plus 2s minus 3. Are you able to factorize it? That one is something you can do in rough work, isn't it? S squared plus 2s minus 3. So here you have as squared plus bs plus c, quadratic, isn't it? So your a is 1, your b is positive 2, your c is negative 3, isn't it? So it is always, the product is always AC, isn't it? So a product of A times C, 1 times negative 3, isn't it? A product of negative 3 and a sum of is always the B value, isn't it? So which numbers give you a product of negative 3 and a sum of 2? If you have that right calculator, 570 or 991, we'll give those answers direct without doing.
Negative 1, 3.
Negative 1 and 3. So you have negative 1 and 3. Because negative 1 plus 3 you get positive 2, isn't it? Then negative 1 times 3 you get negative 3. So the factors are negative 1 and 3. Meaning if you put it there, you have your a squared plus 3s minus s. So this is positive 3 and negative 1, isn't it? Then minus 3, isn't it? So here s is a common factor. You have s into s plus 3. Meaning the other side you must also have s plus 3, isn't it? So for you to remain with s plus 3, meaning you remove negative 1, isn't it? Yeah, negative 1 is the common factor. So negative, you get back to a negative there, isn't it? So if you factorize this, you get s minus 1 into s plus 3, isn't it? So it means from here, what do we have? We have 12s over, this one remains as a quadratic factor. Then this one you factorize into s minus 1 and s plus 3. Are we together? Good. So those are now what we want to resolve into partial fractions. So how do we resolve it? Take the factor you want to resolve. It is 12s over s squared plus 9 into s minus 1 into s plus 3. Are we together? To be equals to, now the first one, this is a quadratic factor, isn't it? When you have a quadratic factor, it is a plus bx over that quadratic factor, which is s squared plus 9, and it has repeated itself once, meaning that is the end, isn't it? Then the next one plus, this s minus 1 is a linear factor, isn't it? So it is just a constant over the linear? Yes. Bs, good. So our x is now s, very good. So this one will be linear, constant over linear, constant is going to be, the next constant is c over s minus 1. Then this one is also a linear factor, so the constant over the linear factor, isn't it? The next constant is d over s plus 3. And remember, they are just to power 1, meaning they are not repeated, isn't it? Very good. So from there, we join them. So we have more than one factor, meaning we use the LCM. You cannot cross multiply more than one factor. So what is the LCM? The LCM must be what you are here, isn't it? Yeah. Which is
s squared
plus 9 into s minus 1 into s plus 3. So you start s plus 9 goes here how many times? You block s plus 9, isn't it? Yeah. It goes the what is remaining there. So you have a plus bs times that, isn't it? Yeah. Times s minus 1 and s plus 3. You are done with that, isn't it? Yeah. Remember, this is one factor, Then there we have plus c. Then you check s minus 1 goes here how many times? You block s plus 1, isn't it? You remain with s squared plus 9 and s plus 3. Then there we have plus b, isn't it? Then s plus 3 goes here how many times? You block s plus 3. You remain with this, isn't it? You remain with s squared plus 9 into s minus 1, isn't it? So you can see this denominator is the same as this denominator, isn't it? Meaning we are comparing this numerator is the same as this numerator, isn't it? Are we together? So we start cases which eliminate s, isn't it? Which take s to 0. So here if you have s minus 1, meaning 1 minus 1 will be 0, So when s is 1, to take s minus 1 to 0, isn't it? So when s is 1, you start from this side of the equation, you have what? You see, it is this numerator is what is equals to this numerator. Meaning it is this 12s which is equals to this numerator, isn't it? So when s is 1, you have 12 times 1, isn't it? You will get 12 to be equals to, on this side of the equation where there is s, you put 1, isn't it? So 1 minus 1, meaning anywhere you see s minus 1 is 0. So the whole of this will go to 0, the whole of that will go to because of s minus 1, isn't it? 0 times everything there is 0, 0 times everything here is 0. So we remain with this middle term, isn't it? 1 squared is 1. So that is 10. Then 1 plus 3, 4. 10 plus 4? 10 times 4, 40. Then 40 times C? 40C. Very good. So you get the value of C to be, you divide both sides by 40 to remain with C, isn't it? So what is C? 3 over? 0.3. 3 over 10. So you get C is 3 over 10. Then you check again. Here we have S plus 3, isn't it? So S plus 3, for you to eliminate S, you put X to be negative 3, isn't it? Yes. Because negative 3 plus 3 is 0, isn't it? Yes. So when S is negative 3, start again. So where there is S plus 3, the whole of this term will be 0, the whole of this term will be 0, meaning will remain with that, isn't it? Yes. So start again, start from this side, 12 times S. 12 times negative 3, negative 36 is equals to this side, isn't it? Yes. So this side, S plus 3, the whole of this term will be times 0 goes to 0, the whole of this will go to 0, isn't it? Yes. Then here, negative squared is positive, isn't it? Yes. Meaning negative 3 squared is going to be positive 9, so there. Yes. 9 plus 9 is 18. Then negative 3 minus 1 is negative 4. So negative 4 times 18? Negative 72 times D, isn't it? So you have negative 72 D. So for you to get D, you divide both sides by negative 72, isn't it? So you divide both sides by negative 72, you get D to be 1 over 2. You are done with that, isn't it? Then you check another one. So you see, taking S to be negative 3 and 1 has already given us 2 answers. So it means the remainder, we can now choose S to be anything, and we are going to get equations which are solvable, isn't it? And the next thing to choose, which is easier to choose, is of course always 0, isn't it? Yes. So 0 is always the simplest to choose. After you've exploited everything, is there any other you can exploit? Because here S minus 1, we could exploit S to be 1. Here S plus 3, we could exploit S to be negative 3. But here is S squared. Negative value and positive value will always be positive, meaning there's no other value we can exploit. So we start with the simplest one, isn't it? Simplest like when S is? 0. When S is 0. So start. When S is 0, 0 times 12? 0. To be equals to, come this side. Anything S times 0, meaning B times 0 is what? Is 0, isn't it? So here we remain with A, then it is times 0 minus 1 is negative 1, isn't it? Then 0 plus 3 is 3. So negative 1 times positive 3. So you get there to be negative 3. So you are done with this part. Then you come here, it is plus C. C you found to be 3 over 10, then 0 squared is 0, plus 9, then you remain with 9, isn't it? 0 plus 3 is 3, so this 9 times 3, isn't it? 27, isn't it? So from there, what is the value of A? Have we reached the end? We've not reached the end. The end is, when S is 0, we have D plus D. What is D? D is a half. Then S 0 squared plus 9 here is just 9, here is negative 1, isn't it? Negative 1 times 9? Negative 9. So use a calculator and join this one. 3 times 27 over 10. Use a calculator. 3 times 27 over 10 plus a half of negative 9, isn't it? Use a calculator, you get? This is 81 over 10 minus 18 over 2. So what do you get? So this is negative 3A. When it comes this side, it becomes positive 3A, isn't it? Then this side you remain with that, which you found to be 81 over 10, negative 18 over 5. That is 11 over 10. What do you have? 3 over 6.
3.6.
I want fractions.
18 over 5. 18 over 5.
18 over 5. Yeah, it will be 18 over 5.
It's 18 over 5.
Yeah, it is 18 over 5. So there you have 18 over 5. Are we together?
Yes.
So from there, what is A? You divide both sides by 3, senior. So you get A to be 6 over 5. You divide both sides by 3 to get A. So we found A, isn't it? we go to the next, we choose any value. We've already chose 1 and 0, which one is closest? It is good not to use negative numbers, isn't it? So we can choose after 1, 0, we can choose 2, because 1 we've already chosen, isn't it? Are we together? Yes. Remember here, at this point we are now choosing any value, because the values which we predicted and we have already utilized here, isn't it? So here you can choose any value in 10, 20, 30, but the simplest one is 1, 2, 3. And 1, 0 is already used, 1 is already used, we go to 2, isn't it? So when S is 2, when S is equals to 2, you start. 12 times S. 12 times 2? 24. 24 is equals to start. A, what is A? This bracket. No, where are we? Here, this bracket. What is A? 6? A is 6 over 5, isn't it? Yes. Then plus B is B times 2 plus 2? 2B into S is 2. 2 minus 1 is 2, isn't it? Then 2 plus 3? 2 minus 1 is 1. Then 2 plus 3 is 5. So 5 times 1 is 5. You are done with that first part, isn't it? Yes. Then you go here. Plus C. What is C? 3 over 10. 3 over 10. Then S is 2 squared. 4. 4 plus 9. Here we have 13. 2 plus 3, 5. So 13 times 5, 65. There you have 60. We are done with this part, isn't it? Yeah. We move here plus D. What is D? 1 over 2. 1 over 2. Then S squared, 2 squared is 4 plus that is 13. 2 minus 1 is 1. 13 times 1 is 13. Can you use a calculator? Start. Here. So here you have 24 is equals to this 5 outside multiplies everything inside the bracket, isn't it? So you have 6 over 5 times 5 you get plus 2b times 5 you get 10b. See there? Since factor in one bracket, multiply all the factors in the other bracket, isn't it? Then use the calculator to join this one. 3 times 65 over 10 plus a half of 13. Calculator. 3 over 10 times 65 plus a half of plus just 3 over 10 times 65 plus 13 over 2, isn't it? What do you have? 26 exactly. Yeah. So you have this. So we have plus 20. So what do? So you remove this term coming this side. Yeah. So it becomes negative, isn't it? Yeah. So 24 minus 26 you have? Negative 2 is now we are remaining with 6 plus 10 in this bracket. There's nothing outside there, isn't it? 6 coming this side, it becomes negative. Yeah. So negative 2 minus 6, you get negative 8. Negative 8. So what is B? You divide both sides by 10, isn't it? Yes. So negative 8 over 10 you get? Negative? Negative 4 over 5. See, we found all the values. After we found all the values, we substitute them there. So the Laplace of x is now what? The Laplace of x is 12 over this. But 12s over this is what? Is what we factorize here. See there? Are we together? 12s over s squared plus 9 into s minus 1 into s plus 3. We've resolved it to partial fraction, meaning Laplace of x, which was the same as this is what is the same as this, isn't it? So substitute a plus bx. What is your a? So you don't have to waste time. You can separate this part on the spot, isn't it? This means it is a over a squared plus 9, then plus bs over a squared plus 9, because this is the common denominator, isn't it? Yeah. So there. Good. So start. What is your a? 6 over 5. Then it is over L squared plus 9. Then we have plus bs, isn't it? Yes. Then what is your b? So it is plus on the numerator here we have bs, isn't it? Yes. Then s squared plus. So you separated them because they are sharing the same denominator, isn't it? A and bs. Are we together? Yes. Then you go to the next one, plus c over s minus 1. What was your c? 3 over 10. 3 over 10. Your c over 3 over 10. Then it is over s minus 1, isn't it? Then your d is a half. So it is plus a half over s plus 3. Are we together there? Plus a half over s plus 3. Now, what do we now do? We know all the Laplace transforms, isn't it? Yeah. When you have a constant over, meaning we want to remove this constant outside. Now this is now what you do. I've used here already. I now look the way it goes. We have the Laplace of x we found to be what? 6. 6 over 5 is a constant, isn't it? Yeah. So you take 6 over 5 outside, then you remain with 1 over s squared plus 9, isn't it? Then you come here, negative 4 over 5 is a constant, you bring it outside, isn't it? So we have negative 4 over 5 because negative into positive is negative, isn't it? Then we remain with s over s squared plus 9. Are you seeing that? Then here the constant is 3 over positive 3 over 10, isn't it? Then in the numerator there we remain with 1, isn't it? And the denominator is s minus. Are we together? Yes. Then the next one, positive a half is a constant, isn't it? Positive a half. Factorize it outside, you have plus a half. Then in the numerator you now remain with 1, isn't it? 1 over s plus 3. Then the next thing is to take Laplace the other side. So when Laplace goes the other side, here you just remain with x, which of course is x of t, isn't it? So when Laplace goes the other side, it becomes Laplace inverse, isn't it? So it is going to be 6 over 5 is a constant, this factor is outside, then Laplace inverse of what? 1 over s squared plus, are you seeing that? Then you, negative 4 over 5 is a constant, then Laplace inverse of what? S over s squared plus 9. Are we together? Then plus 3 over 10 goes outside, then you get Laplace inverse of what? 1 over s minus 1. Then go on. Positive a half, you factorize outside, then you have Laplace inverse of what? 1 over s plus 3. Then you start manipulating it, isn't it? You go to the Laplace table. When do you have a constant over s squared plus a squared, isn't it? Meaning when you are manipulating, you know 9 is a squared, isn't it? So in the next line, you start manipulating. This is a constant over, meaning it is going to be in the form a over s squared plus a squared, isn't it? So it means here in the numerator you must have a in the numerator. So if this is 9, 9 is the same as 3 because it is a squared. So you are able to see a is 3. Are you seeing? So for you to make 3 in the numerator here, meaning you multiply by 3 and you divide by 3. Isn't it? Are you saying you manipulated that? And you are done with that part. You go to the next part. This is s over s squared plus a squared, meaning this part is on the right spot, isn't it? Because in the table we have s over a squared plus a squared, meaning this 9 is the same as 3 squared. Yeah. Meaning there's nothing we are manipulating there, and we are done. You go to the next one. This is 1 over s minus a, and you know there's that Laplace there's a Laplace transform inverse of that, isn't it? Yeah. There's nothing you manipulate there. Are you seeing? The next here you also have 1 over s plus a. There's Laplace of that, isn't it? So you see you are done. So you start. What is your now final answer? Your x of t. This is 3 times 5? 15. So you have 6 over 15. Then what do you have here? When you have a over s squared plus a squared, what is that? Go to the table. It is sine, isn't it? Sine 8, isn't it? And what is your a? 3. So it is sine 3. You are done, isn't it? Then here you have negative 4 over 5. Then in the table, where do you have s over s squared plus a squared? Cos 8, isn't it? So that is cos 8, and your a is 3, isn't it? So this cos 3. Very good. Then you go here in the table. Where do you have 1 over s minus a? Sometimes they give you 8. They give you 8 exponential 8, isn't it? Because we said when here is positive, here is negative, isn't it? Yes. So your a is what? Your a is 1, isn't it? So that is just et, isn't it? Good. So we have there plus 3 over 10 et, and you're done, isn't it? Then here, when you have 1 over s plus a, chorus. See, 1 over s plus a. See, that one is the opposite, negative 8, isn't it? Yes. See, when there is positive, there is negative. Yes. Can you recall?
Yes.
Yeah, and you have the table there. Meaning in the table, whether they give you just one of them, you are able to see the other one, isn't it?
Yes.
Good. So that is the answer there is, your A is? Your A is 3, so there.
Yes.
So it is E,
Negative.
negative 3, exponential negative 3, 3t. Are we together?
Yes.
See, you have solved the question and the 11 marks is not just like that. You are done because you found x of t, the x itself. See, we said x was the function of t. Meaning when you get x, that x is the x of t, what you were looking for. And 11 marks is not like that. That's why I'm saying Laplace transform is a walk in the park. This is the question you are not going to leave in exam. Are you seeing that?
Yes.
Are we together?
Yes.
Good. So let us go to the next past paper.